to be talking about how to simplify radicals, and you will have cube root radicals, square root radicals. And when we talked about radicals earlier in the year, we talked about that your radicals have a number that's called your index, and the number inside here is called the radicand. So I'm just going to have you place that somewhere on your foldable. Okay, you can find a blank space. It's not a whole lot to write. So we basically are going to simply write, give me 1 second. All right, hold on. My little pen doesn't want to write. So the number inside, so let's say that number is 36. Okay, that's called the radicand. And this number inside of here is called your index. So when that number is invisible, then that means it's a 2, because we don't write the square root, the number 2 for square. If it's a cube root, obviously you will see it written inside. Okay, so just making sure you know the vocabulary. So what we're going to be doing is simplifying the radicand. And sometimes it could be a perfect square like this number. Sometimes it may not be perfect. Okay, that would not give us, that's not a perfect square. And we're not going to be getting decimal answers. We actually want to leave it as a simplified radical. Okay, so we're going to just go through the process of how to do that. So on your foldable, you see the perfect squares listed up through 12. And then you also see some perfect cubes, like 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube, and so on. Okay, so that's at the top. So our goal is to take this radicand right here. See, this is 32. Obviously, it's not a perfect square. And we want to find what is the largest factor that is a perfect square that's in 32. Like what times what will give you 32, but we want the largest perfect square as a factor. So if we actually list the factors of 32, like what times what gives us 32, we have 1 and 32, we have 2 and 16, and we have 4 and 8. Those are the factors of 32. So the largest perfect square is 16. So those would be the 2 factors you use. So 16 times 2 is 32. And then you would take the square root of 16 out because it is perfect. And that's how you get the 4 on the outside. And you're left with 4 rad 2. So we're not going to be, expressing this as a decimal. We're going to leave it in simplified radical form. Now this one says the cube root of 54. So again, we're looking for factors of 54, but we want the largest cube root, which would be 27 times 2. When you take the cube root of 27 out, you get the 3. That's how we got the 3 here. And then the cube root of 2 is not a perfect cube, so it stays under the radical. So whatever is not perfect, whether it's a cube or a square, then that stays underneath the radical. Okay? All right, let's move on to first example. So here we are. Here are our factors of 24. Okay, so we're going to start off with some small numbers first. So here are factors of 24. Okay, so which number is the largest perfect square of 24? Everybody? 4. That's the largest perfect square in 24. So we're going to write it as 4 times 6. So when we write it as 4 times 6, so rad 4 times rad 6, that gives us rad 24 when we multiply together. We're just breaking it up into factors. We're going to take out the one that's a perfect square. So what is the square root of 4? 2, so it's 2 rad 6. And that's your final answer. Okay, that's your final answer. Okay. All right. All right, next question. So here we are with 27. So 1 times 27 gives us 27. 3 times 9 gives us 27. So obviously 9 is the largest perfect square as a factor of 27. So we're going to say rad 3 times rad 9. And it doesn't matter if you write rad 9 times rad 3. It doesn't matter. It still equals to 27. So it doesn't matter which factor you write first. Do I always have to write the one that's a perfect square first? No. Okay. So I'm going to take out the square root of 9, which is 3. It goes outside the radical. And then you're left with the rad 3 inside. All right, now, what if there's a number on the outside of that radical already? Okay, what if there's a number out there? So I already know 9 times 2 is going to be the largest perfect square as a factor in 18. Okay, here's a 9 right here. So remember, this is being multiplied. You know, this is really -5 rad 18. So that means there's an invisible multiplication symbol here. So I'm going to say 9 and 2. Okay, so you got to break down that radicand to rad 9 times rad 2. So now when I take this square root of 9 out, which is what? 3, I'm going to multiply it by the number that's already on the outside. So what is -5 times 3? -15 rad 2. That will be your final answer for that. So getting into what happens if there is a negative square root, then that means there's no real number, okay? Because, same thing, because there are no two numbers that you can multiply together to get -64. Because that's what square root means. If I take the square root of +64, and remember that index is a 2, is asking what same two numbers can you multiply together, since this was perfect, to get 64. Okay, this would have been 8. Okay, but there are no same two numbers I can multiply together to get -64. Because a negative times a negative is going to give me a positive, and a positive times a positive is going to give me a positive. So you just simply write no solution or no real number. Actually, it's an imaginary number. That's why we say no real number. This actually comes out to be an imaginary number. So if you want to say imaginary, you're more than welcome to say that as well. Okay? All right. So now let's look at the cube root of 56. Okay, the cube root of 56. So take a look again at your cube roots on the front of your foldable. Which number here in this table is a perfect cube? Because now we're switching gears. 8. So 8 is a perfect cube. Okay, so now when you break down the factors of 56, because we're talking about cube root, not square roots now, we're going to say the cube root of 8 times the cube root of 7. Okay, that gives me, if I, multiply, the cube root of 56. Now, what is the cube root of 8? 2. That means what same three numbers are we multiplying together to get +8, and it's 2. So that goes outside the radical, and I always put a line through it so I know that was the one that was perfect. It goes outside, and then I'm left with the cube root of 7. Okay, so that is how you would actually write it. Okay. All right, next. All right, same thing here. We're looking for perfect cubes that are factors of 40. Here we go again. Okay, 8 is a perfect cube. 8 times 5 gives us 40. So when we break this down, we're going to have the cube root of 5 times the cube root of 8. Okay, I'm going to take the cube root of 8 out, which we already said is 2, and I'm left with the cube root of 5 under the radical. Okay. Okay, so here we are with -7 times the cube root of 16. All right, so we have 8 times 2. So we're going to do -7 times the cube root of 8 times the cube root of 2. Now, since there's a -7 on the outside, when I take the cube root of 8 out, which is 2, multiplied by the -7, is what will that give me? -14 cube root of 2. Pairing. So if you look at the last two questions, well, actually, this is the last one because we already did number 7. But if you look at number 8, it says the cube root of -64. Now, there are 3 numbers, the same 3 numbers we could multiply to get a negative number. Okay, it was not true for a square root, but you can have a negative under the radical for a cube root. Okay, what same 3 numbers can you multiply together to get -64? Anybody? Okay, is it 4 or -4? -4. So -4 times -4 will give you +16, but when you multiply that by another -4, it would give you a -64. Okay, so the answer is just, so what's happening there is -4. Okay. So you can have a negative under the radical if it's a cube root, because you can multiply 3 numbers, 3 negatives to get a negative. However, you cannot multiply 2 negatives to get a negative, right? So let me do